All right, it's 7 o'clock. Hello, everyone. I'm Jack Costello. I'm the chair for the Midwest Rocketry Forum. This is our first workshop of the fall. I'm super excited to be here with you guys and also with our guest, Chris Nilsen, a longtime friend of the club's, a member of our club, an advisor, and a propulsion engineer for our design, build, test program here at Purdue. He's here to give you a Rockets 101. A quick intro for people who are wanting to learn more about rockets but don't really know where to start. We're super excited to put this on for you, and without further ado, I'm going to give up to Chris. And if you have any questions, type them out in chat, and we'll save them for the Q&A portion after he's done presenting.
Yeah, hi guys. So like Jack said, my name is Chris Nilsen. Happy to be here today. There is about a 15 to 20 second delay from when we're giving this presentation to when it's being broadcasted. So Jack said, we're going to save all the Q&As to the very, very end because it'd be a little bit difficult trying to get them all out live. So the purpose of this presentation is to give you a quick start guide. It is nearly impossible to go over all the basics you'll need to launch a rocket in the time we have today, but I hope to give you a good map to go forward and give you some resources on where to learn more. So this is really sort of a teaching you how to fish rather than just kind of putting everything on you at once. Oh. Sorry, there you go. Yeah, so about me, I've been flying high-powered rockets for about 12 years. I've been level 3 certified for a little over 5. I got it it's the summer of my senior year of high school, right before I came to Purdue. I took PSP from about 10 members to a little over 250, and those numbers even grown a little more now with the new leadership. I currently work at Zucro Labs doing a variety of different things. I am the project manager for our Base 11 efforts. I also do a lot of getting ready to do a lot of solid motor testing out here. I'm the advisor for the PSP group. I do a little bit of side work with our rotating detonation projects, and I also do consulting on the side with schools. And I'm just now finally getting into industry, and I'm a master's student on top of that. So I do a lot of rockets, and I'm pretty busy with that. So, all right. So like I said, just a quick overview. We're going to first go over kind of what these things look like, what they are, talk a little bit about Tripoli and NAR, and then give you a couple of quick resources on where to go. So yeah, we'll start from there. So amateur rockets. So you can build reusable rockets that fly really, really high in the air and bring it back, ideally. So you'll hear me talk about a level 1 rocket. I'll explain what a level 1 rocket is a little bit later on in the presentation. But these are powered by solid propellant motors. It's basically the same exact thing that the space shuttle used. There's some small differences, but functionally, it's the same thing. And my beautiful spelling, there's launches across the US that you guys can fly at. I believe there is a Tripoli or NAR chapter in every single state. There's usually multiple. And it's a great way to get started flying rockets. Yeah, so this is just a couple examples of what these things look like, right? So in the middle is what I would call a level 1 rocket, right? So it's about 3.5, 4 foot tall, about 2.5 inch diameter. These things weigh about 2 pounds. And this is what your first rocket will probably look like. The one on the left is from Purdue's entry for the NASA SL competition 3 or 4 years ago. And the one on the right is our hybrid subscale from a very long time ago. You kept a little bit of an idea of that. But they don't have to be simple rockets. They can be clustered, like the one on the left is a pretty extreme example, or they can be staged, right? So people do all kinds of crazy things with these things. And because we live in America, we can launch beer kegs like the rocket on the left. And the picture on the right is a fully functioning porta potty being launched buy a solid motor. So all the possibilities, you can do research and whatnot, but you can also launch a porta potty if you like. So, so the trajectory of this rocket is pretty straightforward. We have, of course, our ignition. We boost for a while, then we coast for a bit, and then apogee, which is the peak of flight. Ideally, a parachute comes out. And then the rocket descends and lands at a relatively low speed, usually about 15 to 20 miles an hour. Now, on more advanced rockets, you heard me talk a little bit about dual deployment. And all that means is that, this trajectory right here for a model rocket or a mid-power rocket, it's only going a couple hundred to maybe 1,000 feet. If a parachute pops out the top, it's going to land still fairly close to the launch pad. But if you're going, 3,000, 10,000, 50,000 feet in the air, that's a very, 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 very long walk. It's miles and miles to get your rocket. So we actually have these little computers that are able to deploy a small parachute, which we call a drogue, and then that takes it down to about 500 feet, and then deploys a larger main parachute to take it, slow it down the rest of the way. So here are the parts of a rocket. So of course, you have your nose cone and your fins at 1 at 7. This is, pretty basic. Everyone here knows what those are. Then you have your airframe, and number 3, you have your avionics bay. And all that's basically a tube coupler. So it's a tube with that has the outside diameter the same as the inside diameter of your larger tube. And that tube houses all the avionics and batteries and recorders, or whatever you want to put in there. 4, that's your drogue parachute, could be your main parachute, it's a parachute. 5, that's your motor. So that gray object in this picture right here is where the motor goes. 6 and 8 are part of the motor mount. So generally, these smaller amateur rockets their motor is not the airframe. So what we do, the motor is basically an aluminum cylinder, aluminum case that is held center. Basically, we take a tube, we take these 2 circular discs called centering rings, and that lines up the motor center in the rocket. So it's a pretty self-explanatory. I mean, there's a lot of little weird lines going in here, but once you get it in your hand and actually start assembling these things, they become pretty self-explanatory. The logic flows pretty well. Yeah, this is kind of general overview of what's going to go out. I'm not going to go in detail on how to make every single one of these or what exactly every single bit piece does here. This is just to get you an idea. If I say something, this is what I'm referring to. All right, so I'm quickly going to talk about the motors here. So these solid rocket motors you can purchase. You don't need to make your own. I mean, you're more than welcome to once you are a little further advanced in your rocketry career, but you can buy these commercially off the shelf, right? There's generally 2 types of motors that they sell. There's reusable and single use. What does that mean? Well, of course, the propellant is a one-time thing, right? You're not going to get that back. But if, as our propellant burns, it creates a lot of pressure. And so we need to contain that pressure. So what the hobby, which it's kind of interesting. So, of course, the hobby came from professionals doing this, and we've now kind of gone back a little bit for the smaller sounding rockets. So the big difference between a disposable and a reusable case is the disposable ones usually have some sort of plastic or fiberglass case, and the manufacturers basically bond the grains inside this case. Not a case bonded grain, which is totally different. But basically, once that's burned, the case is burned enough or in a state where you can't easily reuse it. So there's 2 companies one's called Aerotech, the one's called Cicerone. They both have different solutions for reusables. All the reusable means is that you have a metal case and you buy the propellant, and then you essentially put the propellant in this case with some O-rings and some spacers and some grease. And that's all tightened down into this casing. And then you put that in your rocket and you fly. A common question I get asked when people start this is, well, which one should I get? Let's just say we have a G motor, which I'll get to in a second. That will cost you about 25 bucks, right? If you're going to buy a single-use motor. A reusable motor with a propellant grain itself is usually about 15 to 20, but there's an initial cost for that aluminum casing that could be anywhere from $80 to $100. So if you plan on flying a lot, if this hobby really interests you, then I would say, hey, get a reusable casing. If not, but if you're only going to fly once or twice with your club, you're doing it more for a social activity, stick with the single-use casings. It's going to save you some money in the short term, because there's no reason getting hardware for that. All right, so this is the motor designation. So the amateur community has this little code here to define what our motors are doing. So H123-14W describes everything we need to know about the motor. So the H, or whatever letter is in front, describes the impulse class. And I will chart on that in a second to explain what those classes are. The second number, the 123, is the average impulse in Newton seconds. Okay, so if we know the range of our impulse class and then the average impulse, we can kind of guesstimate how much it's going to burn, how long it's going to burn for. They don't use that for burn time, but a little guess you have it there. That 14 is a delayed charge. So one thing I didn't mention in the beginning of the presentation when we had that simple rocket trajectory is if we don't have any computers on board, how does the rocket deploy its parachute? Well, I have another diagram in a second. Once the propellant grain stops burning, there's basically a delayed charge, basically a smoke grain that burns for a finite amount of time that we know. And so that 14 means that after the motor's finished burning, we have 14 seconds before that grain hits a small black powder charge. And once that black powder charge ignites, it pressurizes the tube, pushes either the nose cone or coupler out, and pushing your parachute out. So we can adjust that delayed charge. And so if you do some math or do a simulation, you're able to know when your rocket's going to be at apogee. And you can, say, okay, well, if I'm going to be coasting for 8 seconds, I need to take 6 seconds off my delayed charge to make sure my parachute's coming out at the appropriate time. And there's tools to do that. And the last letter is W in this case. I call that the color code. So each manufacturer can put some additives in their propellant to make the propellant a different color. So I think copper sulfate is blue. They put titanium sponge in there, basically these little pieces of titanium, and gets a really cool spark effect, like a giant sparkler. It's pretty neat. But they'll change. It's really no performance meaning to that at all. It's just more of a visual thing when you buy it. So this is the impulse class chart. So eighth, quarter, and half A's, you never ever see those. You probably won't be working with these ever. But as you can see, A through G is low and mid power. Anybody can go to a Hobby Lobby or a Hobbytown USA. I think Walmart has some, Amazon. Anybody can go out and get these motors. There's no licensing, there's no permits, it's nothing. You can just go in there and get it. When you get to high power, level 1, 2, and 3, you need certifications in order to get those motors. I'll talk a little bit more about that later. But H&I is level 1, JKL level 2, and MNO and up is level 3. If you're flying anything above an O, there's a whole new world, or a whole other world we won't get into today. This is generally. Now, you may notice, actually, I just realized this chart doesn't do a great job of explaining, well, I guess it does. Each letter is twice as powerful as the one before it. So if you have a full A, right, or a full B, that's twice as powerful as an A. If you have a full, a C is twice as powerful as a B, and so forth. So you know, you might not think it's a big jump from G to H. Is a big jump from a G to an I that's a little bit different than an A to a C, right? There's a lot more total impulse to that. All right, so here's a rocket motor cutaway. So all solid rocket motors pretty much look exactly like this. So at the top, it's labeled here 6 and 1. We have our closures. And all these closures, they just keep everything together, right? So you can think of those as our caps. Right in the middle there, we have our kind of the orange color, we have our propellant grain. Now, normally there would be a hole going up and down the middle of our grain. This picture I found is nicely color coded, but it doesn't really show the grain. But there should be a hole going up and down that orangey grain part there. And the actual grain's like almost like a grayish black rubber. Then we have our nozzle. 5 is a smoke charge / delay grain I was talking about. 7 is our ejection charge. And of course, 4 is that aluminum case and liner. So I'm not going to go over how exactly these things work. I believe that's another workshop later on, but give you an idea of how these things go together. Now, you may be looking at this if you've never seen a rocket motor before and thinking to yourself, that's a lot of little pieces. How in the world do I assemble that? It's actually pretty straightforward. You know, they come with pretty detailed instructions, and you know, it takes a couple times to get used to it, but by your fifth build, it'll be you know, pretty routine for you. This is what an aerotype motor looks like. Cesaroni is a little bit different. They actually pre-package all of the grains in a nice plastic case that you put into your metal liner. So if you don't like to get your hands a little greasy and put together some things, Cesaroni would be a good option for you to purchase your motor. All right, so what are the things made out of? It's generally cardboard, wood, and fiberglass. You can use carbon fiber and aluminum essentially, but you really don't, it's not necessary for this scale of rocket. You'll find larger high power rockets, especially the ones that are going to competition, will use carbon fiber and aluminum. But if you're kind of doing this as like really an intro to rocket club at your school or whatnot, you know, stick with the basics. You'll find success a lot faster. And if you have a machine shop in your backyard, go right ahead. But stick with cardboard, wood, and fiberglass when you first start out. Epoxy is used for pretty much everything in terms of assembling these things when you have these smaller rockets. You know, super glue is okay for smaller high power rockets, but you know, if you have a 2-inch and above, you probably need some epoxy. And epoxy can be JB Weld. I know a lot of people use laminate epoxy, which you really probably shouldn't use, but you know, any 2-part epoxy is probably going to be sufficient enough for this. Yeah, and these wood and fiberglass components are easily attainable. So if you've ever tried to cut fiberglass, you'll know that it is a pain. There's a bunch of dust that goes everywhere. It destroys your blades. But everything you need to build a rocket is available for purchase, pre-made, no cutting involved. You just got to buy it, assemble it, and you're good to go. When you get more advanced, you can start making your own parts, but don't feel like you need a full-fledged workshop to build one of these. You could do everything you need to do to build a pretty decently sized rockets in your apartment. Avionics. So we use little altimeters to measure the altitude and velocity of our rockets. So these aren't necessary to fly if you're just starting out. If you have a delayed charge in your motor, if you want to know the altitude, great. If not, no big deal. But as you get up to J's and above, they generally don't come with delay charges, and they also usually go a lot higher than a G or an H or an I would. So you need a dual deployment altimeter not only to deploy the parachute to the rocket, but to kind of track it and kind of guide it where it's going to go come down at. Because you don't want to be flying, because after about 3,500 feet, it goes out of sight. So you can't see anything. So if You fly really high up and your main parachute pops out. You have no idea where that thing is at if you don't have some sort of tracker on board. But with these dual deployment altimeters, with a small little drogue on an apogee, they come down, somewhat straight down. You can kind of get a visual on it before the main pops out, and you can better track your rocket. All right, simulations. I'm going to talk a little bit about OpenRocket. I just threw these quickly in the presentation before I started. But there's a free open source software called OpenRocket. That program will allow you to kind of design your rocket. I'll show you a picture of it in a second, but it's free. I really encourage you to do it. The guy that made this, he put a document on what he did to go into it, and it is very, very nice. Unless you're if you're an aeronautical engineering student or an MA student, I do encourage everybody to sit down, do the rocket equation, and do the basic ballistic trajectory at least one time, so you have an understanding of what is going on. But you can do that on a piece of paper. But when you're starting to design your larger rockets, this software, if you're competing in the SL competition, for example, right? Unless you have somebody who's really, really, really excited about trajectories and simulations, there is really no reason to try to make your own code for this. I know our team did it, and I was very against it until they got to a point where they matured it a little bit to where it exceeded the capabilities of OpenRocket. But if you want, if that's your ultimate goal, then great, go at it. But you really don't need anything else other to get started out with. Here's what it looks like. So let's say you want a nose cone, right? You press the nose cone button, you specify how big you want it to be, and it just adds it on there. It's really that simple. I don't think there is I looked for one, a step-by-step guide how to use OpenRocket, but if you play around it for a few minutes, you'll find it's pretty self-explanatory. And the cool thing about this, since it's open source, if you know a little bit of Java, you can do a lot of cool things with it. I think this example here had a simulated roll control device on it, and it's pretty neat. And since the motor is only the motor files it gives, it's just thrust over time, right? So if you wanted to simulate your hybrid or your liquid rocket, you can do that by the program thinks it's a solid, but you can trick it into thinking you can trick it to have it do for a liquid. It's kind of neat. Cool. All right, so I want to quickly talk about the Tripoli Rocketry Association and the National Association of Rocketry. These are the two organizations that regulate amateur rocketry. They don't have any legal authority on everything, but basically the amateur community has kind of self-regulated itself because they don't want some random person coming off the street, purchasing a large motor, and then just putting something together in their car and flying and potentially hurting somebody. So while there's no law saying that it's not like a federal law that says you cannot buy an I-motor without a certification, you're not going to be able to get one. You're not going to be able to fly one unless you have it. And honestly, you need to learn how to crawl before you can, walk. And if it's that big of a monetary challenge or technical challenge to get a level 1, 2, or 3, you're gonna have a lot of trouble building any bigger rocket in any other case. So kind of reiterate that. So if you have this idea to build this giant single stage to orbit, whatever you think of, but you don't want to get your level 1 first, well, because it's either too expensive or too hard, you probably need to go back and reevaluate your project and start from the beginning and go up. So there's local chapters all over the US that have monthly launches. Anyone can attend them. I have not heard of a club that charges a head fee to just attend the launch. And these launches are great because not only do they supply launch equipment and an FAA waiver, they also provide the insurance and land. So getting a piece of land to launch a large high-power rocket is pretty hard to do the proper way. So And you don't need to build your own launch pad. You just build your rocket, bring your motor, and they'll have the appropriate equipment to fly your rocket. And you'll be all safe with the FAA. Yeah, and these organizations do the certifications. Which one should you join? They're essentially the same thing. Tripoli does focus a little more on the experimental high power end, and NAR does focus on the low power modeling aspect a little more. But in terms of certifications, they're both the same. And if a local club is a Tripoli or NAR club, if not both, they recognize each other's certifications. So if the only club is a NAR club in your area and you want to go fly at a Tripoli launch because you need a bigger launch field, you won't need to recertify. You can go there because they recognize both things. I didn't actually tell you guys what these certifications actually entail. Sorry about that. So a level 1 rocket certification, all you have to do is fly an H or an I motor and get it back down and have the rocket be in a state where it can fly again. That's it. So you can, there's no test involved. The flight safety officer will give you a quick quiz on your rocket, just to make sure that you know things are going to stay together. But it's pretty basic. And you should be able to pass it with flying colors. I haven't heard anybody not getting a level 1 because they didn't know the technical aspect of what they were doing. You could theoretically go to a launch, never seen a rocket before, buy a kit, build it in your car, and fly it the same day and get certified. Level 2, there's a little more involvement. Of course, you need to be level 1. And then there is a test you got to take. I believe it's 100 questions, 50 safety and 50 technical. You do a little bit of studying for it, but it's nothing too crazy. It's multiple choice. There's only 3 answers, and I think the answers are the same on the practice exam as the actual exam. But they're so you need to spend some time for that. The rocket, of course, gets a little bigger, and you'll probably need to do some electronics works in it with your altimeter. Nothing too crazy. Level 3 is a little more involved. You'll need to have, I believe it's 2 what they call TAP members, at least for Tripoli. And all that means is that there's 2 experienced rocketeers watching over your build. So it's like a mini, they're going to ask for a proposal probably, and updates on your build, and they're going to be watching over you, not physically while you're in the room assembling it, but you have some decent documentation on what you're doing and how you constructed it before and after, before you launch. You also need to fly a level 2 rocket with electronics at least 1 time. So that's kind of the caveat to get there. Level 1 will probably run you, when it's all done, in probably $120. Level 2, it's decently pricey at probably $300 to $400. If you, and level 3, it's pretty expensive pretty quick. So that's why I recommend start small. If you're really excited about the hobby, it's awesome. Don't rush too quick because you're only going to spend more money on mistakes. A mistake on a level 3 is a lot more expensive than a mistake on a level 1. So start small, build your skills up to the larger rockets. How to get started? Pretty simple. Go get a kit, right? So Apogee rockets, Mad Cow, Public Missiles, Wildman. If you just type in high power rocket kit, there's a bunch of searches, right? And they'll usually say, hey, this kit was great for level 1 or whatnot. Look for a 29 or 38 millimeter motor mount on the description. Any of those are be okay for you to fly. And just learn some build techniques, right? The Rocketry Forum, it's a really nerdy and geeky forum, but there's a lot of useful information on it or in it. Download OpenRocket, get yourself familiar with that. You need it for larger rockets and attempt to launch, right? So even before you really buy a kit, go online right now. See where your local prefect is. You go hang out. Normally, it's either the first or third Saturday of every month. It's different for every club, but that's normally what they are. Yeah, go out to a lunch. Members are usually more than happy to help you out. Everyone's there to have fun. There's no competitions at these things. There's no, it's very, very, very laid back atmosphere. Of course, with an emphasis on safety, but other than that, there's no stress in going to these things. So yeah. So 2 quick resources. Apogee Rockets is honestly probably the best, step one for anybody. They do have a lot of mid and low power stuff on there, but I mean, if you're just out of high school, if you're in high school, so freshman in college and high school, this is the best place to start. We have a bunch of design videos, a ton of construction techniques. Everything you need to know to get your rocket to fly is in this website. I'm not paid by them. I just love these guys so much. They also have their own version of OpenRocket called RockSim. It's $100 though. They do essentially the same thing. RockSim has a couple extra features, but it hasn't really come to that big of a problem for me. So yeah, definitely Apogee Rockets or Apogee Components is a fantastic resource to start out with, especially the construction tips. It's amazing. I've helped probably close to 200-ish people get their level 1 over the past couple of years, and it's amazing how hard epoxy is for some people. So it's good for everyone to just get a basic understanding of, hey, here's the proper way to mix the epoxy. Here's some tips on how to keep it all together and whatnot. So, and then the NASA high-powered video series Counterpart document. This is a pretty comprehensive document. So this is for high-power rockets. So there's a competition called the NASA Student Launch, and NASA put out, I think, an 8-part video series on how to get started with rockets. And it's pretty, the video series is decently, I don't want to say intense, but it uses the basics. But this book goes into great detail on all the construction techniques, what you need in your rocket, different ways of mounting things, and all sorts of stuff. I highly, 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 highly recommend you download this document and read it. It's going to be a lot to take in, but this will be basically your ultimate guide on what to do to get you into this hobby. Of course, it's focused a little more towards the competition because it was written for that, but the content in that document applies to everything you're going to be doing for high-powered rockets. So I highly, highly recommend that. All right, that's in the presentation. Please feel free to type any questions in the chat. There's a good 20-second delay, so it's going to be a second before I get to the question. That's our presentation.
Yes, please feel free to ask questions. We're on here for schedule about another 30 minutes. Yeah. I don't see any questions right now. However, Chris, I guess just kind of one clarifying question for people who would be watching. So you say that Apogee has a lot of kits available. So when you mean a kit, what do you mean by a kit? Like what comes in those kits and what do you need to buy outside of them?
That's a good question. So a kit normally comes with most everything you need to actually build this thing, right? So it'll come with an airframe, a nose cone, a motor mount, a parachute, a shock cord, everything but the motor. The motors are not included with any of the kits. So if you buy a kit, you'll probably need to get some sandpaper, some 2-part epoxy, and maybe a hobby knife, and you should be good to go on constructing your rocket. And most of them only take about 2 to 3 hours to build. So it's not it shouldn't be a 3-month-long project for you. So if you want to get your hands dirty really, really quick, you don't need to a lot of hours to this.
Awesome. And then I guess one more just kind of clarifying question for anyone who's watching that I feel would be a great help. What happens if you launch your level 1 and it fails? What happens if you launch any amateur rocket and it fails? What do you do next?
All right, so if you get a level 1 rocket, you fly it and it comes down and crashes or breaks a fin off, either buy a new kit or fix it up and fly it again. There's no, like if you fail on a rocket launch, there's no like period where you're like banned or anything. You can try and try again. So if you launch a level 1 rocket, goes in the dirt, and you buy a kit at the launch site, put it together in the backseat of your car, you can fly again the same day, I believe. I think for level 2 and 3, there is a period where they recommend you wait a month, wait till the next launch to kind of get your things in order again and look over what you did. But yeah, if you fail level 1, just fix it, rebuild, and try again. There's not a penalty. There's no delay or period, anything like that. You can keep on going.
Awesome. And I guess one final thing for anyone is, can you share an interesting story you had from any launch you've been to before?
Yeah, so it's actually the very first launch I ever went to. It took me about 4 months to convince anybody to take me out to this rocket launch because they thought it was dangerous. I'm like, it's not dangerous. Of course, this is 6th grade me trying to beg my parents to get out there. My grandfather finally took me out to one of those launches, and he's like, "You sure this is not? You sure this is safe?" I'm like, "Oh yeah, it's safe. It's safe. It's safe." I read online, it's safe. The very, very first launch we saw, it was a glider, right? So it doesn't have a parachute. This thing was probably about, it looks like a plane, right? So it goes up, and instead of a parachute, basically pops out some fins, and it glides back down. Well, this thing was a fairly large one, and it was about, its wingspan was about 4.5 feet. It was a pretty big one. It went up off the pad, and immediately when it came off the pad, it did a direct turn towards me and landed up. I mean, this was with an I motor, so it's a pretty decent rocket, and it landed about 10 feet from my grandfather and I. And he's like, he just kind of gave me this look, and he kind of laughed it off. But yeah, I almost died on my very, very first rocket launch. But that was the closest call I got.
Awesome. All right, I think we should wait about 5 more minutes to see if there's anyone who pops in with more questions in the chat.
Yeah, sure.
Otherwise, it seems like people are starting to leave, so then we'll end the stream and then put this online for anyone who wants to watch it again later at a different time. And if you're in the chat, if you're watching and you feel like your question is stupid, there's no such thing as a stupid question. We'll answer them. I guess while we're waiting, it's a good time to say, oh, Omkar, I'm not sure if I'm pronouncing your name correctly. Yeah, you're very welcome. We're really happy to be able to put this on for you guys. And I guess, like, I haven't even done my level 1 yet personally, and yet everyone I know who's done it seems to have had a really good time with it. Even if you fail, you usually get a good story out of it. So I would highly encourage everyone to at least look into it if you can. In that case, I don't think there will be any more questions coming in. I'm going to end the broadcast right about now. Thank you everyone who showed up. And next week we'll be coming at you with the workshop from launch photographer Trevor Malman. He's going to be giving a presentation on launch photography strategies, what that entails, and some of his experiences with that. We're really excited to be putting that on for you guys. All right, see you next week. And also, don't forget, our podcast episode is coming out on Saturday on your preferred streaming platform. Stay tuned to our social media. And if you haven't, register on our Midwest Rocketry Forum website to get updates on when content releases. In that case, thank you, everyone.